Today's lesson objective, students will classify triangles and find angle measures. So there are two ways that we can classify triangles. We can classify them based on their sides, and we can classify them based on their angles. So first, looking at how we would classify based on sides, the question you want to ask yourself is how many sides are congruent? So if we look at a scalene triangle, none of the sides are congruent on a scalene triangle. Every side has a different length. If we're talking about an isosceles triangle, then that means at least two congruent sides. And then an equilateral triangle, all three sides are congruent. So since an equilateral triangle has at least two congruent sides, you can technically say that it is also isosceles. But generally speaking, you're going to use the most precise name for them. You're going to call them equilateral. But like I said, technically they are also isosceles. Okay, and then we talk about classifying by angles. An acute triangle has three acute angles. Every single angle is less than 90 degrees. If we have an obtuse triangle, that means that there is one obtuse angle. It would be impossible to have two obtuse angles because if you did that, then your triangle would never close. So there can be only one obtuse angle. If it's a right triangle, then it's the same situation. There can be only one right angle because, again, if I had two right angles, the triangle would never close. It wouldn't be a triangle. And then the fourth way would be equiangular, which means all three angles are congruent. So if all three angles are congruent, then the angles are always 60 degrees. And it turns out that equiangular triangles are always equilateral triangles as well. So, for example 1, we're going to classify a triangle on a coordinate plane. We're going to classify it, and then we're going to determine whether or not it is a right triangle. So first of all, it says classify by its sides. So by sides, that means, is it scalene, is it isosceles, or is it equilateral? So the first thing I'm going to have to do is find the lengths of each side. And so I'll use the distance formula, or you can use the Pythagorean theorem. But we take the change in x and we square it, and we add the change in y squared to that. So if I'm looking at RT here, my change in x from -3 to a +3 is 6. My change in y from 3 down to -1 is 4. So 6 squared is 36. 4 squared is 16. Add those together and I get 52. And so 52 is the same as 4 times 13, so I can simplify that radical, and RT would equal 2 root 13. Okay, if I check ST, looking at this one here, so my x is changing by 2, going from 3 to 5. My y is changing by 3, going from a -1 to a +2. And so 2 squared is 4, 3 squared is 9, so ST would equal the square root of 13. And then finally, I need to find RS. My change in x, I'm going from a negative 3 to a positive 5, that's 8 squared. And my y only changes by 1. 8 squared is 64. 1 squared is 1. And so I get that RS is equal to the square root of 65. So since all of my sides are different, or in other words, I have no congruent sides, therefore I know it is a scalene triangle. All right. Now I need to determine if it is a right triangle. So the second thing I'm going to have to do is find the slopes. All right. So if I look at the graph, it looks like RT might be perpendicular to ST. So those are the slopes I'm going to start with. So the slope of RT, I'm going down 4 and to the right 6. So my slope is negative 4 over 6, which reduces to negative 2/3. And then if I find the slope of ST, here I've got a rise of positive 3 and a run of 2. So I get 3 over 2. So my slopes have a negative 2/3 and a positive 3/2. They are opposite reciprocals. If I multiply them together, they equal negative 1. And as a result, I know that RT is perpendicular to ST because their slopes are opposite reciprocals. So that means if the lines are perpendicular, I'm making a right angle. If I have a right angle, then that means that triangle RST is a right triangle. So that would be the rest of your answer for that problem. Okay, so the triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So if I have the measure of A plus the measure of B plus the measure of C, I add them together, they will have to equal 180. So in example 2 here, we've got a triangle with some algebraic expressions for the angles. I know that if I add up the angles, the 2x, the 3x, and the x, then they have to equal 180 degrees. So if I combine my like terms, I get 6x equals 180, and then you just divide by 6, I get x is equal to 30. So now if I go back and plug these in, that angle is 30, that angle is 60, this angle is actually turns out to be 90 degrees. So it turns out that this particular triangle is a right triangle. And it's also scalene. None of the sides are congruent. Of course, this particular problem, they were just asking what the value of x was, but it doesn't hurt to think about what kind of a triangle it is. All right, so the next thing we're going to talk about are exterior angles. Students will use the exterior angle theorem to find angle measures. So with exterior angles, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So looking at the figure here, my exterior angle is angle 1 here. And then my remote interior angles are A and B here. Those are my remote meaning removed, right, not right next to it, right? Remote interior angles. Okay, so in my figure then, the measure of angle 1 is going to equal the measure of angle A plus the measure of angle B. So then we can use this to solve problems and find angle measures. So we're going to use this diagram to find the measure of angle DCB. So first we have to figure out the value of x. So again, my exterior angle equals my first remote angle plus my second remote angle. So looking at the picture, this is my exterior angle here, because it's outside the triangle. So 3x minus 9. And that has to equal the two remotes added together. So I've got one remote angle of 73 degrees, and the other one they're just saying, calling x degrees, or x. So 3x minus 9 equals 73 plus x. I then subtract x from both sides. And I'm also going to add 9 to both sides. And so when I do that, I get that 2x is equal to 82. And so x equals 41. But I'm not done yet. I need to know the measure of angle DCB. So the measure of angle DCB is equal to 3x, so 3 times 41, minus 9, which is 123 minus 9. And so the measure comes out to 114 degrees. So that would be your answer. The measure of angle DCB is 114. Okay, so I'd like you to try this one on your own. We are going to find the measure of angle 1 for this one. Pause the video. Okay, so you should have set 5x minus 10 equal to 40 plus 3x, and so you get x is 25. I plugged that into the 5x minus 10 to determine that the exterior angle was 115 degrees. And since angle 1 and the exterior angle are a linear pair, I know they add up to 180. So 180 minus 65, or 180 minus 115, I get that the measure of angle 1 is 65 degrees. This concludes this video.